hi, grade 12s. Hello, hello. Welcome to your Wednesday show for Life Sciences. I am Looney and Aslam. How are you?
You are Looney, you are admitting that.
Yes, I am Looney.
Oh, that's your name.
Yes.
Hi, Mindsetters, how are you doing? Looney, I'm fine. You didn't ask, but I'm fine.
I said hi, Aslam.
Oh, okay.
How are you?
I'm doing well.
I'm good, thanks. You didn't ask me now. What are we
can
doing
go
for the
on like
matrix?
this
No,
all
it's
day,
fine.
you know
It's fine.
Because
it's
we're
fine.
talking about homeostasis, we're going to be balancing the books all the time. This is what we're doing, guys. We're doing homeostasis in humans.
All right. Mindsetters, I hope you're excited for the lesson. We also have a special guest in studio with us. Hello, Kawe.
Hi, how are you?
I'm good, thanks. How are you?
I'm good, thank you.
So tell us where you're from, what you're doing here, why are you here?
Well, I'm from Amatimol Secondary School. It's in Azorville, and I am from Kagiso, Riverside specifically, Kagiso 2 in the West Rand.
Okay, cool. And you do grade 12?
I'm in
Life
grade 12, yeah,
Sciences.
it's my last year. Life
Right.
Sciences, Mr. Khan is my teacher.
You need to
loving
make
it.
sure that you're not here like in grade 10.
No, I'm in matric, the white jersey,
Okay,
the white
cool.
jersey.
All right, I hope you enjoy the lesson as well.
I will be
We've
most
got
certainly.
lots of stuff for you. I'm sure Aslam is going to ask you questions.
Yep.
It's going to be a fun show. Mindset is to interact with us. All you need to do is go to facebook.com/learnextra. That is our Facebook page. And then our Twitter handle is @learnextra. And then if you want show notes, videos, and schedules, and if you want to revise and go through everything for your exams, past papers, videos, and everything, it is on learn.mindset.co.za. That is our website, and it's quite user-friendly, guys. So go check it out for everything that you need to learn more and learn extra. And then remember, if you want to win this awesome calculator from Casio, all you need to do is complete the test yourself questions from the notes, but I will post a link for the entry form. The entry form has questions, and you need to fill in all your details. So you fill everything in, you submit your entry, and you have until Friday to do all of that. 12 in the afternoon, the entries are done, it's closed, it's glass. So you have this time, you can watch the show. After the show, then you can enter the competition. But for now, Aslam.
Thank you so much, Looney. Guys, we are dealing with homeostasis. And homeostasis coming from two Greek words actually. Homeo meaning the same, and stasis meaning the state. So homeostasis simply means to remain in the same state, literally. But we take it a little further when we're going to do the definitions as we're going to go on, and I'm sure Kawa is going to help us when we get there. So what are we actually concentrating? Firstly, you've got to define this word homeostasis, or the term homeostasis. Secondly, you've got to be able to say that within the cells, the conditions within the internal environment is absolutely important. And the internal environment in humans is the tissue fluid. In other words, the cells are living within this tissue fluid, and whatever must be kept constant, when we talk about keeping it constant, must be in the tissue fluid. We must also list the factors within this tissue fluid that must remain within narrow limits. What are these factors that we are talking about? Good. Then we must describe the control of levels of the following through negative feedback. Now, last week we dealt with negative feedback. What is a negative feedback mechanism, how it operates, and we looked at two important ones. We looked at the role of negative feedback with thyroxine and with glucose. So look at what we're looking at here now in this chapter. We want to know how negative feedback works with glucose. So this you've already done in endocrine system. It's finished, it's done. We will look at it again, but it can be tested in this section or the other, but they're in the same paper, so it doesn't matter. Carbon dioxide, it's new, but Kawan, when did you do about carbon dioxide in your life? In grade?
11 or 10.
In grade 11. Kawa has probably done it in grade 11 and 12 already. That's why you're going to get a doubt. But you've already done that in grade 11 when you did gaseous exchange in humans. You had to talk about what happens if the carbon dioxide levels become too high. So you've done that already as well. So we're revising it today. And with water and salts, you also did in grade?
Yeah, 11.
Grade 11, yeah. With excretion under the kidney, you learnt about how we control water, how we control salts, and in the previous section, that means in the endocrine system, you also learnt about the hormones ADH and aldosterone. So those are the hormones that are dealing with those two guys. Further, you need to identify, now that's the first part. Up to there is the first part. Now, in this part here, this is a special type of homeostasis, and that is thermoregulation. And in this section, you need to know the different parts of the skin that are involved. Notice, look at your exam guideline, and when you see your exam guideline, you'll notice that not the whole structure of the skin is prescribed. It's only those parts of the skin that are involved in thermoregulation. That's very important, because you're going to learn too much of information, and when they ask you to label the diagram, you may give too little or too much. Okay? Describe the role of each of the following in the process of thermoregulation, and these are the three things that we are interested in. Even in this section, you need to only worry about sweating, vasodilation, and vasoconstriction. Those are the things that you need to worry about. Challenge question. Kawe, it would be nice if you take down some notes while we're talking about this, because later, tell him, who's going to answer this question for us?
He is.
He's going to answer the question because he's the expert,
Yes.
the special guest.
Genius.
Okay? The special guest gets the reward of answering the
Answering
challenge question.
question.
The question is, alcohol inhibits the brain from making the hormone ADH. Drinking alcohol, it suppresses the pituitary gland from releasing ADH, or the brain from making. So in actual fact, it suppresses the hypothalamus from making. He said making, not releasing, but making this hormone. Why will drinking alcohol cause a person to urinate more? Why will drinking alcohol cause a person to urinate more? Okay, so that's the first question. And today we have two. The second one, simple question, tabulate the differences between the nervous system and the endocrine system that you have learned before. Okay, good. Let's move on to the summary. Summary starts with our acrobatic man, much like me, Kawan. Hey? What's that, Luli?
No, you would be
I do
upside
the other way
down.
around.
Yes.
I thought you tell me that. Oh, what are we seeing there? We're seeing clearly the man trying to balance, and homeostasis is all a balancing act. You'll notice in your answers for homeostasis, your last sentence will always bring it back to normal. Whether it's going up, it must come down. If it's going down, it must come up. What? Where? Balance. That's what we're talking about. What is the internal environment that we're talking about? It's the tissue fluid. Now, let's look at this particular diagram. There's an arteriole on one end and a venule on the other end there. I used the wrong colors in the wrong space, but you know what we're talking about there. In this area, there's pressure build up because the artery or the arteriole is under pressure from the heart, because the heart is pumping blood into the artery. The arteries become arterioles, and then they become capillary. Here's your capillaries here. On the venule end, there's nothing pumping the blood. The blood is flowing slowly back to the heart. So there's pressure here. There's more blood coming in here and less blood going out there. So what happens, some of this blood, some components of this blood leaks out of the blood vessels, and this green that you're seeing all over there by the cells, the fluid it makes. It's not green in your body. Okay? This fluid we call tissue fluid. This is how tissue fluid forms, and you would have learned this under this section in grade 10, the lymphatic system. What are those factors that we need to control? There's a list of them. Carbon dioxide, oxygen, urea, salts, glucose, water, temperature, and pH, among the more important ones. These things have to be kept constant in the tissue fluid. If they go off, there will be problems. We'll talk about that in the questions. Negative feedback mechanism, and this one is showing you the one with carbon dioxide. Notice the mechanism that is involved is nothing new. All we have done is we substituted words where we spoke about thyroxine and thyroid gland and pituitary gland last week. Now we're talking about other parts of the body. You must remember there must be a stimulus, there must be a control center, and there must be a response. In any not only negative feedback, but in any coordinating system, these three things are very important. There must be a stimulus. Any change in the environment, stimulus. There must be a control center. It must be fed to a control center. And the control center must initiate a response somewhere. How does it happen here? Let's say for some reason, the blood carbon dioxide levels fall, the pH, let's start here, sorry. If this is the normal carbon dioxide and blood pH, why do they talk about carbon dioxide and blood pH together? For your exams, it's not that important, but why do they put these things together? Simple. If carbon dioxide levels increase in the blood, the carbon dioxide breaks up into carbonic acid and bicarbonate ions. This carbonic acid will affect the pH. Okay? So that's why we're talking about that. So if the carbon dioxide is normal, and for some reason the carbon dioxide increases above the norm, what will happen? First of all, these things here we can talk about as an extra order. Diseases raises carbon dioxide levels. Some diseases can cause the carbon dioxide to increase. But carbon dioxide does not have to wait for that. You could be exercising, you could be running a marathon. Because the oxygen is not getting there fast enough and your carbon dioxide is not being released quick enough, your carbon dioxide levels will increase. What does this do? It drops the pH levels in the blood. What does this do? It's picked up by chemoreceptors in the carotid artery and in the medulla oblongata. So the medulla then is your control center. This is where it's fed to. And what does it do? It stimulates the increased rate and depth of breathing. And it can also stimulate a faster heartbeat. So what's happening? You're breathing in faster, so you're getting in new oxygen and you're getting rid of carbon dioxide. And if your blood is, your heart is pumping faster, your circulation is improved, so oxygen gets to the cells faster and carbon dioxide is removed. And in this way, there's an increased removal of carbon dioxide from the body, and the blood carbon dioxide levels comes back to normal. That's what happens. So we don't talk of much of a decrease in carbon dioxide in this negative feedback mechanism. We mainly talk about an increase. The problem with this is a slightest increase in carbon dioxide lowers the pH. And if the pH is affected, Kawe, what's the problem?
The enzymes.
The enzymes would be denatured because enzymes are specific to pH. And if the enzymes are denatured, then you won't be able to respire. Eventually, you may die. So because there is such a delicate balance, the carbon dioxide levels, the minute they increase even slightly, they kick in this whole mechanism that we have just discussed. Again, just to remember, the carbon dioxide levels increase, it drops the pH. This pH drop is picked up by special receptors, chemoreceptors in the carotid artery and in the medulla oblongata. Medulla oblongata acts as a control center. It sends messages to the diaphragm and the intercostal muscles to contract and relax faster. In simple terms, it increases the rate and depth of breathing. And what does this do? It gets rid of carbon dioxide from the body. The heart rate is also increased so that carbon dioxide from the cells are removed faster. In this way, the carbon dioxide levels comes back to normal. Notice, nothing more different from what we spoke about last week. We've only changed the words, but the mechanism is the same. This one here is just showing you, again, to remind you of the nephron in the kidney. And it's this area here especially, where the levels of water are controlled. What happens in that area is sodium ions are pumped out of the tubules. So the sodium is positively charged, and chlorine will follow passively because it's negatively charged. So in other words, we're increasing salts in this area here, around the tubule. So what have we done to the water potential of that area, Kawet?
Decrease it.
We have decreased it. The minute you add solutes to a solution, you decrease its water potential. At the same time, if ADH is secreted, it causes this area here and this area here to be more permeable to water, meaning permeable, allowing water to pass through. So in that case, we will reabsorb more water, and the water will be back into the blood, and our urine will be more concentrated. That means there will be less water in your urine. If there's too much water, something else will happen. Now let's look at what happens here. Here's the water content of blood, which is normal. If you eat too much of salts, or you're sweating too much, this level of water can be low. Where's the control center? The pituitary gland. What does it do? It releases ADH. What does that do? It stimulates the reabsorption of water by the kidney, in the kidney. And therefore, we have a concentrated urine, and therefore there's more water into the blood, and therefore water level comes back to normal. If for some reason you're drinking too much of water and you're not sweating so much, then the water content is too high. Again, the control center doesn't change. It's still the pituitary gland, secretes less, or releases, less ADH, and because of this, low water reabsorbed, high water into the urine is dilute, less water into the blood, and therefore it comes back to normal. High, lower, low, higher. With that, to you, Luni.
All right. Mindsetters, we are going to take a break, but a very quick shout out to Moronga Khatle. You have won yourself this awesome Cassia calculator, so congratulations to you. Mindsetters, if you also want to win this Cassia calculator, all you need to do is complete the test yourself questions from the notes. There is a link on our Facebook page. Follow everything that's on there. All the instructions are pretty simple. All the questions are quite simple because it's like multiple choice and very short questions that you have to answer. Then you'll stand a chance to be like Moronga and win this awesome Cassia calculator. So at that said, let's take a very quick break and we'll see you straight after this. Welcome back, Mindsetters. You're still hanging out with Luni, Aslam, and Kawe, and we are doing what? Homeostasis in humans.
Just say. Good. Short and sweet.
Yes.
Okay, we were busy with our summary. Let's continue. The last part of that work that we need to look at is thermoregulation. The first topic under that is that you need to know the diagram of the skin. Specifically with the labels that we are showing you here. This should be sweat duct. Okay, let's carry on. The diagram of the skin, we got there's a caption we have. The top layer is called the epidermis. The bottom layer is called the dermis. We have a sweat duct there, this part there. This is the sweat gland. Here's one sweat gland on this side and another one on that side. And we have many blood vessels there, capillaries or blood vessels that we find. Those are the important labels for thermoregulation. There are also other parts of the skin, as you can see. We have hair that is there. We have the hair shaft. We have the erector muscle, etc. Remember that if you're asked to draw the diagram of the skin, these labels are not required. It's only what I have told you about. So let's just, those are not required. What we've shown you, that's what you need to know. Good? And now let's see how our balancing act takes place in terms of thermoregulation. Notice I told you for every negative feedback mechanism, even this can be seen as a negative feedback mechanism. For every of these reactions or mechanisms, there must be stimulus, there must be a control center, there must be a response. Let's look at it here. For some reason, the body temperature rises. That's the stimulus. The body temperature rises. So it's too high for some reason. It's hot outside, you're exercising, you may be doing other things, but your temperature goes up. Okay? You may be sick also. You may be having a fever. In that case, it's slightly different though. So the receptors in the skin and special receptors in the brain as well, they sense this. And what do they do with this? They send this information to the control center, which is in the hypothalamus, by the way. Okay, I'm going to just do it shortly there. Okay. Notice also, by the way, how they're linking the nervous system into this whole thing. This is homeostasis, but notice they're talking of an afferent pathway. Not so much for exam purposes, but it's nice to see how our sections are clicking together. Afferent pathway means a sensory neuron or afferent neuron is taking messages from the receptor to the central nervous system. Sensory neuron, covered? Yeah. Okay. An efferent pathway or motor neuron would send messages from the control center to the effectors. And by the way, the effectors will bring us the response. Okay. What happens in that story? Sweat glands are activated. What happens? There's more sweating, more, don't just say sweating, say more sweat. And the evaporation of this sweat is what cools the body. Not just the sweating. It's the evaporation of the sweat that cools the body. And also, the blood vessels to the skin is not written there, dilate. So more blood goes to the skin surface, and therefore more heat is lost by conduction, convection, radiation, and evaporation. And on the other end, remember, this is the opposite of what we've just learned. If the body temperature falls for some reason, it's cold outside, you know, you're talking about it in the news, you better start getting ready, Kawe, from tomorrow. They say tomorrow, lucky, it's only in the afternoon, they say. But I felt it's quite cold today already. Yeah. So we may have problems. But if the body temperature falls because of that, then the receptors will pick this up again. And the information is going to go to the control center. All this is the same, whatever happened on the top. Same thing. And this control center is going to send a message to the effectors of the body again. Here now, things will be different. The sweat gland will be less stimulated, so there's less sweat, number one. Number two, shivering begins. Shivering leads to friction. And friction makes heat. We can also talk of the blood vessels. The blood vessels now, the blood vessels constrict. And if they constrict, less blood goes to the skin surface, less heat lost by conduction, convection, radiation, and evaporation. Also, we can bring in another story here, and that of thyroxine. The thyroid gland will be stimulated to secrete more thyroxine. Thyroxine will increase the metabolic rate, and this will give rise to an increase in body temperature as well, and therefore the temperature rises to normal. To round that up with a flow chart now, same story. Normal body, increase thermoreceptors. They're going to go to the control center, increasing sweating, vasodilation. Decrease to normal. Summarize again. Decrease thermoreceptors, shivering, vasoconstriction, increase in body temperature. And this one is for Kawe especially. And for you also, Luni. Make it balance, eh? Always be in homeostasis. Yeah. Good. Kawe, now we're ready for you. Yeah. This is where the real fun begins. Okay. Right. Question 1 says, define the term homeostasis, Kawe.
Well, it says maintenance and regulation of the internal environment as it is under the influence of any external stimuli.
Good, good, good. You see this boy, you better watch him. So
clever.
You better watch him. Maintaining a constant internal environment despite any changes on the outside. So in other words, it's getting cold outside, but your body temperature will remain plus minus
37, somewhere there.
Around 37, 36 to 37 degrees. Yeah. Good. Okay. Name the internal environment of humans.
In what sense?
What is our internal environment? Where are the cells living?
Where the cells
living? First slide. Yeah. Which was that? Tissue fluid. Yeah. You got that one wrong. Just mark it down in one black dot on his name. Huh? List 4 factors that must be kept constant in the internal environment of humans.
Maybe temperature would be the pH.
Good. Okay. Good enough. Going in the right direction. Water, carbon dioxide, oxygen, salts, glucose, temperature, pH. Just on that note, let's just quickly talk about why. Why water? If there's too much water, you're going to get swelling in the body. The water is going to give you additional weight. There's retention of water. This can cause pressure on the kidneys, etc. If there's too little water, you'll become dehydrated. Good. Carbon dioxide, If there's too much carbon dioxide, what was the problem earlier we said?
The pH.
pH will drop and that's going to affect the enzymes. Oxygen, if there's too little oxygen, your metabolic rate will be low. If there's too much oxygen, your metabolic rate will be too high. We don't want it that way. Salts, if there's too much salt in the body, your water potential of the tissues will be too high, you won't reabsorb water, and vice versa. Glucose, if there's too little glucose, you won't have enough energy. If you have too much glucose, you have sugar, diabetes. Right? Temperature, if temperature rises too much, it's going to affect what again? Enzymes, because high temperatures denatures enzymes and low temperatures inactivate them temporarily. The same goes with pH, we spoke about that. Good. Explain how the concentration of carbon dioxide is regulated in the body of a person who is doing a lot of work for his team while playing soccer. Okay, from you, I only want to know what's going to happen to him. Is he going to have too much carbon dioxide or too little?
Well, obviously he's playing, he's going to have too much of a carbon dioxide.
He's going to have too much of carbon dioxide, excellent. Why? Because he's playing a game, he's running, his body is using, respiration is at a high level, so too much carbon dioxide. So let's see what we're going to do. This is grade 11 work essentially, by the way. So what will happen is that the body will secrete less TSH first of all. B. This is one answer, this is one possible answer, but this is not what we wanted there. I must have left something in the wrong place again. I'm going to get wrapped on the knuckles. Okay, explain how the concentration of carbon dioxide is regulated. Kawa, you want to help me now?
Yeah, I can take that.
Because I got it 0.
Yeah.
Out of 7, I got 0.
Well, you'd say as right now as you're playing soccer, right? So obviously remember in your body the metabolic rate of your cells and your cells go up. Obviously we're talking about cellular respiration.
Right.
So there's an increase in the production of carbon dioxide.
Right, so then what's going to happen to pH?
Yeah, so your pH obviously now will drop.
So carbon dioxide up, pH low,
And
where it's
obviously
going to
then
be picked up?
in the hypothalamus, from correct?
No, not the hypothalamus.
Yeah.
Which other part?
Your chemoreceptors will pick the
Yeah,
lower level,
chemoreceptors
yeah.
will pick it up.
Then
And
obviously the entire concept of homeostasis comes in.
That's right.
Yeah.
And that will go to the medulla
Oblongata.
oblongata.
Where your ventilation rate must now be increased.
That's right. Which will stimulate, increase rate and depth
Of breathing.
of breathing.
Yeah. So now we're looking at your ribcage, your intercostal muscles. You're breathing at a faster rate.
Good.
Yeah.
So we're talking of the intercostal muscles, Kawe says, and the rib cage and the diaphragm, all that's going to do that. So what we're going to do, this way we'll remove
More carbon dioxide.
the carbon dioxide, and the carbon dioxide will go back.
Yeah. And you're taking in
normal.
more oxygen.
Good. You're seeing the actual answer there. This one here is probably left over from somewhere. Gremlins in the system. Okay. Let's move on. A normal, this one here, you're going to have to read properly now. A normal blood glucose level is 1,0 milligrams per centimeter cubed. Normal insulin level is 0,5. A group of people with normal blood glucose and blood insulin were tested over a period of 5 hours. The average values were calculated and are indicated in the graph below. Okay. Before we go into this question, I want you to ignore these figures here, because they just slipped in there. Okay, good. Now we'll be okay. Now we need to look at the graph and answer the questions. What are they telling us? Glucose and insulin levels in blood over time. Can you see the independent variable and the dependent variable are there? Time being the independent variable and the levels of insulin and glucose being the dependent variables. Therefore, they are found on the y-axis. And in this case here, you're getting both are there in that story there, right? So we're talking of blood, glucose, and plasma insulin there. The dotted line is insulin. There's your time in hours. Notice the units are given with the axes there. So when you're drawing a graph, remember the skills we need to transfer. Not only are we talking about the question, but also how do we draw graphs? Okay, so that's what we are talking about there. Notice that 1 to 2, 2 to 3, 3 to 4, 5, all equidistant apart. And the same here, 0,246. You can't make this 0,2 and make this 0,5 and so on. That's going to go off, so you won't get your mark for interval. What is the glucose level at 3 hours after the start of the investigation? 3 hours after the start of the investigation. So where must we go, Kawe? 2,
First you go to your
3, right?
3, then
And then
go straight
go up.
Yeah. Then turn to your left, and the
And go to
corresponding
that,
figure.
it's 1,4. And don't forget
The
the
units.
milligrams per centimeter cube. Good. Describe the relationship between insulin and blood glucose by referring to the graph. What can we say?
So the
As glucose increases,
insulin secretion
insulin
increases.
also increases. And what does this do? It causes a
Change.
decrease in the glucose level. That's what we need to say there. They just ask for the relationship in terms of the graph. Because look at the next question. Explain how the blood glucose level increases between 2 and 3 hours after the investigation starts, even though no food is eaten. Okay? Here's 2 to 3 hours. This area here, no food is eaten. How come the glucose level is increasing in this point here, up to there? What could have happened, Kavit?
Well, if you're not eating anything at that point in time, obviously the glucose level, they'd be the working of the hormones.
Which one?
Yeah, insulin, and you have your glucagon.
Glucagon, excellent. So in other words, glucagon would have been secreted because there's no food, and this is going to increase the glucose level. Notice you can't talk about insulin too much here because insulin is on the decline here. Okay? Good. Name the organ in the body which produces insulin. That's easy.
Pancreas.
Pancreas, good. Excellent. Okay, notice here, we could have asked you so much more still on this question here in the exams. We can talk about, explain the negative feedback that insulin is involved in. So you're going to talk about when there's high glucose level, this will be picked up by the pancreas, which will secrete insulin, and insulin will go to the liver in the blood and cause a change of glucose into glycogen and fat. It will also ask the cells, instruct the cells to absorb more glucose to be used, and this will bring down the glucose level to normal. Homeostasis, okay? Good? Now we come to thermoregulation. Study the diagram below and answer the questions that follow. They're giving you a diagram of the skin. There's only 3 labels, A, B, and C. Okay. They want you to label layer C and part B. That was a giveaway already. Layer C would be the
Epidermis.
The epidermis. Good. Remember, that's the epidermis, and the rest would be the dermis. Okay? And part B, this one here,
Sweat gland.
that's the sweat gland. Remember, we have a sweat gland, then we have a sweat duct, and on the top will be the sweat pore. Those are the labels that you need to know. Everything around the sweat you need to know there. Okay, good. Describe the changes in the above organ when the outside temperature is 7 degrees Celsius.
Obviously, the body now needs to try to retain.
What type of, what are we talking about? Low temperature or high
There
temperature?
will be low temperature.
Low, obviously,
Yeah.
because our body temperature is around 36.
Yeah.
Okay, so you were saying, Kawen?
So obviously, the body will try to retain as much heat as possible.
Right? So what must happen?
Obviously,
First
there's-
of all,
yeah,
how does the body know about this change?
with the receptors.
Receptors
Yeah.
will pick up the stimulus.
Yeah.
In this case, cold. Body temperature has dropped. They send this message to
The brain.
hypothalamus, because in this particular thermoregulation, hypothalamus is the control center. The hypothalamus then instructs who?
With the sensory neurons.
No.
No.
Which parts of the skin?
Would be the dermis.
No. You'll speak a little louder for us also, right?
Okay, yeah.
It's going to cause the blood vessels. I'm going to tell you which, and then you're going to tell me what it does to them, okay? Sweat glands and the skeletal muscles. Okay?
Yeah.
Now you're going to tell me, let's put another color so we can make it easy for the listeners there or the viewers. But hypothalamus sends to the blood vessel. What happens to the blood vessels?
They need
It's cold,
to,
remember.
yeah, they need to constrict.
So we talk about vasoconstriction. Constriction. Guys, vasoconstriction means the blood vessels to the surface of the skin become narrower. You can't say thinner and thicker. You must use the word constrict and dilate when we need it. So they will vasoconstrict, less blood to the skin, therefore less heat will go to the skin, therefore less heat loss by conduction, convection, radiation. To the sweat glands, are they going to be more or less active?
Less.
Louder, right?
Okay.
Less
Yeah.
active. And therefore you'll have less sweat. And therefore less heat will be lost by evaporation of the sweat. Skeletal muscles, what happens to them? They start to do what? They start shivering.
Shiver, yeah.
And shivering has friction, and friction produces heat.
Yeah.
And we can add one more, the thyroid. More thyroxine,
Yeah. Increases metabolic rate.
metabolic rate up, and this creates body
Heat.
heat.
Increases temperature.
Loni.
Thanks, Aslam. Mindset is let's take a very quick break, go get some water, get some juice, do some stretches, and we'll see you straight after this. Welcome back, Mindsetters, from that break. A reminder, guys, when we get to the part where we ask your questions on the show and we don't get through all of your questions because we run out of time and it's time to go home, just remember you do have so many help desks to send your questions and ask your questions there. One I can tell you is learn.mindset.co.za/helpdesk. And remember, guys, the Life Sciences Learn Extra Help Desk is proudly brought to you by Excel. So please make sure you make use of it. Thanks.
Oh, thank you, Loni. Right, guys, we ended with the last question with what happens on a cold day. I just want to show you something very quickly here. Cold, and we did cold, so let's look at that one first. What did we say? That the stimulus is picked up by the receptor. From the receptor, it goes to the central nervous system, in this case to the hypothalamus. The hypothalamus sends messages. Blood vessels and skeletal muscles and sweat glands. If it's on a hot day, what's going to happen? Stimulus will be picked up by the receptors, and this will go to the CNS, to the hypothalamus. And what the hypothalamus does, it sends messages to the blood vessels, it sends to the sweat glands, and it sends, not to the skeletal muscles in this case here, right? It sends to these two guys, mainly. Okay. So can you see that your answer, Kawe, is the same in both, but the responses in each will be opposite to each other. Let's look at, yes, I can maybe do that. Let's see. Blood vessels, in a hot day, will what happen to them?
Dilate.
They will dilate. And the sweat glands will be more active. And therefore, they will secrete more sweat, and the evaporation of the sweat will cool the body. Remember, you must say that last part, it will cool the body, or it decreases the temperature back to normal. Whereas on a cold day, the blood vessels constrict. The sweat glands are less active, and the skeletal muscles shiver. We can also add here the action of thyroxine. Increase the metabolic rate to raise the temperature back to normal. So that's an easy way just to remember the two. Remember, the one is the opposite of the other one. Good, now we go to the challenge question. So what are you figuring out there, Professor?
Well, when you think about it,
Louder, don't forget.
Okay, so the question is, alcohol inhibits the brain from making the hormone ADH,
Yeah.
right? Why will drinking alcohol cause a person to urinate more?
Yeah.
Well, for me, firstly, the chief thing is for understanding what ADH is. We know it's a hormone, but the key word there for me is the word diuretic, right?
Right.
When you think of the word diuretic, you're thinking urinate more.
Right.
So if it's anti, then it's against that exactly. So now alcohol, remember, it stops, you could say, the hypothalamus from secreting your ADH, right? And you need to understand that your ADH greatens the permeability of your renal tubules.
Normally,
Yeah. So that more water can be reabsorbed from the urea, in that sense, into the blood vessels, right? To increase
from the tubules
into the blood vessels, right? So now, obviously, if now they said it inhibits the brain from making the hormone ADH.
Right.
So if less of your ADH is secreted, then obviously
now he's answering the questions.
Yeah.
Up to now, he was giving us a background, right?
Then
less ADH, right?
Less ADH, right? Then the permeability of your renal tubules decreases.
Decreases, right? Good. So the permeability of the tubules, distal convoluted tubule and collecting tubule more specifically, is decreased, and therefore?
So understand that in these renal tubules, say you have water of a given quantity, say 40 decimeters cubed or whatever it may be, right? So obviously, if less water is retained now, it means you'll urinate more, as compared to if, say, it had reabsorbed.
Less water is
retained.
Reabsorbed.
Yeah.
Reabsorbed. Good, excellent.
Yeah.
On the pathway, little bit of fine-tuning needed, but we are there. What we are saying is that there's less ADH, so the permeability of those tubules is less, so therefore that means more water will remain in the tubule, and therefore more water will go to the bladder, and the bladder is going to fill up quicker, and therefore you will have to empty it out quicker. Okay? So ADH causes the kidney to absorb water from the urine. A decrease in ADH will cause more water to be lost in the urine. We've given you the long cut to the same answer. But you needed to say about the permeability if it was a longer question. This was just to see whether you understand. The thing is, you didn't learn about this in your syllabus. But the clue was given to you here. They told you what was the story, that there'll be less ADH. From there, you needed to look at the functions of ADH and link it up to what happens in the nephron of the kidney. So again, just to recap, if there's less ADH, the permeability of the collecting tubules and the distal convoluted tubule decreases, less water is reabsorbed. Now let's understand this reabsorb. Reabsorb means there was water in the tubule, and it's normally destined to go to the bladder, from the bladder, urethra out. When we reabsorb, we mean we take it back. It went in via the Bowman's capsule. Now we want it back. Why? Because the body needs it. So we take it back. Now alcohol is impairing this function. So it decreases the secretion of ADH. Less water will be reabsorbed. More water to the bladder. More water in the urine. In fact, the urine will be dilute in that case. Good? The second one, not too difficult. Some differences between the nervous system and endocrine system.
Well, in your nervous system, we're dealing with impulses, electrical impulses.
Let's see if our order follows yours.
Oh, okay.
Okay, that doesn't not yet.
Almost,
Right? The one is it's carried by neurons, and the other one is carried by hormones, right?
Yeah.
You were saying? I think this will be the next one.
Yeah.
Here you go.
Yeah.
Nerve impulses in the nervous system and that side.
Yeah.
What's the difference?
Nerve impulses and the carried in ducts.
Yeah,
Oh,
not ducts, but hormones.
Yeah.
Hormones, okay? Nerve impulse here, hormones on the other
Nerve
side.
impulses, yeah.
Another difference would be
Very quick.
travels very quickly, happens now. I'm talking, you listening. You are looking at the TV, you watching me, okay? It's instantaneously. However, with the hormones, travel slowly. It takes long. More than that, nerve impulses travel along nerve fibers. We can use the same thing there on top. And here, travels in the blood. Specific effects on effectors. That means it's going to cause the muscle to contract or relax, or the sweat gland to secrete more sweat, whatever. Immediate and specific. Whereas the hormonal effects is a wide effect. It's not just one thing. It's wide effects on target organs that it does to work with. Does not last for very long. It's short term. It happens now. You're hearing me. You listen. It's finished. It's done. Whereas take the growth hormone, for example, in your body. It's with you for the rest of your life. Mainly between during the teenage years, where it's actually very fast in that time sometimes, and it can last for a long time. So those are the differences between the nervous system and that. I felt putting this question here ties up what we have done from the nervous system from here. Remember, what have we done up to now? We have spoken about a response to the environment. Remember, these last two topics, endocrine system and homeostasis, may not be included in your June exam. If you're writing a common exam, please check with your teacher whether these sections are included or not. The actual June exam will stop by the year. These are extra bits that we've carried on, so you've got one step ahead when you get back to school in the third term. Luni,
Yes.
some questions that our kind professor can answer for us.
Okay. Wow, Woody Precious is asking, can you please ask Aslam to repeat question 2.2 and 2.3?
2.2 and 2.3, so he can't do it. I have to do it myself. 2.2 No, that was challenge. 2.2 and 2.3.
Yes.
Describe the relationship between insulin and blood glucose by referring to the graphs. We're looking at the graph here. As blood sugar increases, the level of insulin also increases. And as blood sugar decreases, the level of insulin also decreases. But remember, the increased insulin is what is causing the blood sugar level to come down. So once that blood sugar level comes down to normal, then there's no need for insulin. So insulin level will go down again. The minute the glucose level goes up again, you notice in this case it wasn't too high, so it's staying around there. And thereafter, after a while, when it peaks, that's when the insulin level goes up again. This is the relationship. Means if you're looking at this graph, explain what is happening to insulin and what's happening to glucose and how they are related to each other. Okay? And 2.3. Yes. Why does it increase between 2 and 3 hours? In this time here, there's nothing being eaten. How come the glucose level is increasing again? Insulin brought it down. It came down below the norm. Now it's going up again because the glucose level is going up, because you need glucose. But let's go back to the original story. What is the normal blood glucose level? 1,0 milligrams, right? Now let's see what happens here. When insulin acted, it brought this glucose level to 0,8 there. This insulin level must be there by 1. How did it get to 1 and beyond? First of all, glucagon may have converted glycogen and fat into glucose. And in that way, the glucose level starts rising there. There would have been somewhere here food eaten where it goes even beyond that 1 gram per decimeter cube, whatever it's calling there. Are we understanding that, I hope?
Okay, thanks. And then Siabulela is asking, do receptors in the hypothalamus also become stimulated except the skin receptors during a change in temperature?
Yes, definitely.
Okay. And then Siabulela is also asking again, does aldosterone, yes, have any impact in maintaining pH of the food?
pH of the food,
yes.
Aldosterone?
Yes.
Not really. Aldosterone deals with salt, amount of salt in the blood. If aldosterone levels increase, it increases the reabsorption of salt. When is this done? When there's too little salt in the body, aldosterone will be secreted by the adrenal glands, and this will stimulate the reabsorption of sodium, especially from the tubules, and then chlorine will follow, and the salt level will increase. It's important for the salt level to be okay there, or a particular level there, to keep the osmotic, or rather the water potential between the tubules and the tissue surrounding it. What is ideal is that the tissue fluid around the tubules must always have a lower water potential than the tubules, so that when we want to reabsorb water, water will move from the tubules to the tissue by osmosis.
Okay, and then from James Baloy, what is the relationship between hyperthyroidism, and then what is GOITRE?
Goiter.
Goiter and hypothyroidism.
Okay, let us ask our professor, because that one is a bit high for me.
Oh.
Hyperthyroidism. Hyperthyroidism, what would that mean?
Yeah. Well, remember, hypo, whenever you think hyper and hypo would be high and hypo would be low.
First of all, he said one important thing there, or two. Oops. Where were we? There, down. What did he say? Luni, do you remember what he said? Hyper
Is
high, and hypo
is low.
Low. I always say, think about hyperama, hypermarket, lots of goods, or hyperactive, somebody is overactive. So hyper means there's too much, and hypo means there's too little. Okay? And because of this, there would be disorders. Now, relate these disorders first and foremost to the functions of thyroxine. They were metabolic rate, heart, nervous system. So if it is too high, Kawe, what's going to happen to the metabolic rate?
It will increase.
It will increase, and what happens to your weight? Will you increase in weight or decrease if your metabolic rate is high?
Metabolic rate is high when you decrease in weight.
You will decrease because you'll be burning food too fast, so you won't have time to store food, and therefore the weight will decrease. Okay? The heart and the nervous system the heart will beat too fast, and the nervous system will be stimulated too much. So you can have anxiety and the rest of it. If you have a low thyroxine in the body, then what happens then?
Metabolic rate decreases.
The metabolic rate will decrease. And because the metabolic rate will decrease, you will gain weight, and your heart rate and your nervous system will be on the slower side, lethargic, slow, laid back, maybe too laid back. Okay? Are we okay with that one? I'm hoping.
All right.
Yes?
And then from
She also asked about goiter, sorry.
Yes.
You also asked about goiter. Goiter is the swelling that takes place in the enlarged thyroid gland, which leads to a swelling in the neck region. It is mainly associated with a lack of iodine in the diet. We must explain at this stage what we did last week, that for thyroxine to be produced, it requires iodine. Therefore, when you're buying salt from the supermarket, look at what's written there. It will say iodized salt. So the iodine is added to the salt, and we take that iodine in. In addition to that, having seafood regularly, not seeing food, but seafood, you know, seafood. Looney?
Yes,
seafood, like what?
Like prawns.
Yeah, I'm on a seafood diet.
Really?
The more I see food, the more I eat. Eh? Okay, all right. So you eat seafood, it's going to prevent that. So it becomes enlarged in that area. What they have to do is to increase iodine in the diet and or surgically remove the goiter.
Okay. And then from Violet Rantamane, what is the role of adipose tissue in the skin?
Adipose tissue in the skin. Adipose is a fancy word for what, Kawe? Speak loud, eh?
Slipped my mind.
Slipped your mind. He slipped his mind, so now he can't talk loud also. Okay. Adipose tissue is fat. Fat cells. Adipose tissue is fat cells. What are their purpose in the skin?
Insulation.
They will be there for insulation. They will keep the heat in or out, or the cold out, or whatever you want to talk about. Insulating layer. Fortunately for you, however, the adipose tissue is not part of the exam guideline. But nice to know that if we are a little bit on the weightier side, we can keep warmer for longer. And also, we'll have reserved food for longer as well. Yes, Looney. Is that all? That's bad, Looney.
It's bad?
That's bad.
Maybe it's because they understand.
Okay. Good. Right, guys. So we have covered what we needed to do in that one there. I just want to make a small note about the test yourself questions. Remember, those questions are put in such a way that it's testing you the whole section, terminology, matching, and I put in an additional question, this time on a graph or a little paragraph there. Please look at those questions, because that means it extends to what we are doing here. You have more questions to go over. With that, keep well. Looney, over to you.
All right, Kawa, do you have any shout-outs to send to your friends?
Yeah.
Loud.
And quick, okay?
Quick and loud.
Yeah. Well, you could say my class 12A, my family, yeah.
All right.
Watching,
okay, cool. Yeah. Thank you, Aslam, and thank you, Kawe.
I want to shout out to Looney.
All right. Thank you for tuning in. We love you so much, and we'll see you next week. Goodbye from us.